Hey everybody, this is a project I've been working on over the past few weeks. It's an electrostatic gridded ion thruster, works with corona discharge. Very similar to the NSTAR thruster pictured here that was used on the Dawn spacecraft 2 series. There's a couple key differences. Here the NSTAR uses a 2.3 kilowatt power supply and mine is only 18 watts. Also, I've reversed the polarity of these grids. The NSTAR uses a positive-negative grid. I use a negative-positive grid. This is basically because I don't have a vacuum on the outside, like this does over here where the ion beam is, and therefore I don't have a pressure gradient, so it actually just works a little bit better the other way. The NSTAR also uses a continuous discharge, while mine is more pulsed. You'll see when I actually demonstrate. Also, I use air plasma instead of xenon plasma, but that's just because I don't have access to xenon gas. So the way this is set up is right here we have a 6 volt 3 amp power supply. This is hooked up to a momentary switch, just hooked up to this voltage booster. I'm not entirely sure how it works. I think it's a Tesla coil encased in there, but I'm not sure. I bought this on Amazon. It basically said it would give me 700,000 volts, but I've measured it. It's more like 100,000 volts. And basically these are all hooked up here. You have this splitter here. This is the cathode, this wire here. This first grid here is a negatively charged grid. This second grid here is a positively charged grid. Minus 50 kilovolts, plus 50 kilovolts, plus 50 kilovolts. So the way this works is this wire here will ionize the air. It'll cause the air to become negative, basically, negatively charged. I'm sorry, it will cause it to become positively charged. And that'll get it pulled towards this negative grid here. Basically, positive air gets pulled towards negative grid, right? And then once it gets pulled toward that grid, it actually gets stuck in this PVC pipe. Because this other side here is positively charged, and these positively charged ions are not able to pass this potential difference, this electric charge field, until they have enough energy. So basically they're stuck in here, getting hit by other particles and reionized, until they have enough velocity to pass this grid. And once they pass this grid, all the energy they expended getting past it, they basically regain as the particles are repelled out the back of the thruster. Now, this isn't that dangerous. I measured this to be about 0.02 milliamps. Although, due to the capacitive nature of this, especially the pulse discharge, it's probably up to 1 milliamp, but that's still about, not lethal. But it does hurt. So now I'm going to show you how this works. Now you have to keep in mind that the actual 2.3 kilowatt thruster used on the spacecraft generates only like 92 millinewtons of thrust. So this is going to generate very little thrust, but it's noticeable, which is cool. There we go. Oops, got some discharge there. You can see the paper actually does get blown back. I don't know if you can see the corona discharge here. If I move it closer. Oh. Anyways, this is how this works. If you can see a little bit of glowing when it doesn't spark, that's actually the corona discharge of the air being ionized. Anyways, I hope this was informative.